In C, an identifier is any name you give to something in the program: a variable, a function, an array, a label, and so on. Identifiers are grouped into three conceptual classes. Variables are names that stand for storage locations whose content can change while the program runs. They are the boxes you can put different values into at different times. Constants are names that stand for values that never change after they are defined. Think of them as a sealed envelope that always contains the same number or character. Keywords, also called reserved words, are special identifiers built into the C language grammar such as int, while, return. The compiler treats them as commands, not as user-defined names, so you cannot use them for your own variables or constants. The purpose of this classification is to let the compiler enforce rules such as type checking, storage allocation, and syntax parsing, and to give programmers a clear mental model of what can be modified and what cannot. A declaration tells the compiler the name and the type of a variable. A definition also reserves storage. In C, a declaration can be combined with an initialization, assigning a starting value like int count equals 0. Scope determines where the name is visible. Block local scope inside braces of a function. The variable lives only while the block executes automatic storage. Example, for int I equals 0, I less than n, increment I is visible only inside the loop. File global scope outside any function. The variable is visible to all functions in that translation unit. Function prototype scope, identifiers that appear only in parameter lists of a prototype. Storage class specifiers affect both lifetime and linkage. Auto, the default for block variables, gives automatic storage, created on entry to the block and destroyed on exit. Static, inside a function, gives the variable static storage, kept for the whole program but block scope. At file level gives internal linkage, visible only inside that file. Extern declares a variable defined elsewhere, giving it external linkage. Register is a hint to keep the variable in a CPU register. No addressable storage, still automatic scope. A variable must be declared before it is used. If you try to use it without a prior declaration, the compiler issues an undeclared identifier error. C provides three ways to create constant values. Literal constants, the raw value written in the source code, for example 42 3.14, the compiler embeds these directly into the generated code. Symbolic constants with hash define, a preprocessor macro that substitutes text before compilation. Example, hash define pi 3.14159265535. Double area equals pi times r pi is not a variable. The preprocessor replaces every occurrence of pi with the literal value. Const qualified objects, actual objects stored in memory but marked read only after initialization. Example, const double pi equals 3.14159265535, cannot be modified later. Double area equals pi times r. The compiler places pi in a read-only section, often .raw data, and will generate an error if you attempt to assign to it. The three forms differ in when the value is fixed, preprocessor versus compile time versus run time, and where it lives, immediate constant, macro substitution, or stored object. The C language reserves 32 keywords in C99/C11. C18 adds a few more. Auto break, case char, const, continue, default, do, double, else, enum, extern, float. For goto, if, inline, int, long, register, restrict, return, short, signed, size of, static, struct, switch, type, def, union, unsigned, void, volatile, while, underscore align, as, underscore align of, underscore bool, underscore complex, underscore generic, underscore imaginary, underscore no return, underscore static, assert. Control flow, if, else, switch, while do for break, continue, goto, return. Type specifiers. Int, char, float, double, void, struct, union, enum, signed, unsigned, short, long, underscore bool, underscore complex, underscore imaginary. Storage class and qualifiers. Static, extern, auto, register, const, volatile, restrict, inline. Other, size of underscore align as underscore align of underscore no return, underscore static, assert, underscore generic. Each keyword tells the compiler how to parse the surrounding tokens. For example, size of expects a type or expression and yields a compile time size, while static changes storage duration and linkage. Area equals pi times r. Pi is a mathematical constant. Its value never changes. In C, you can represent it as a const qualified object. const double pi equals 3.141592653589793. Or as a macro, define pi as 3.141592653589793. R is the radius, a measurement that can differ for each circle you compute. Therefore, R is a variable, double R equals 5.0, double area equals pi times R times R. If you later change R to 7.0 and recompute, area will change, but pi stays the same. This illustrates the core difference. Variables are mutable storage locations, constants are immutable values. C identifier rules are simple but easy to trip on during exams. Legal characters, letters A to Z, digits 0 to 9 and underscore. The first character cannot be a digit. Case-sensitive, count and count are different identifiers. Maximum length. The C standard guarantees that at least the first 31 characters of an identifier are significant. C99/C11 guarantee 63 for internal identifiers, but most compilers treat the whole name. Reserved words, keywords see previous topic, cannot be used as identifiers. Common pitfalls. Using a keyword accidentally, for example int return equals 5 semicolon, leads to compile error. Starting a name with a digit 1 cent value is illegal. Confusing underscore and hyphen, total minus sum is illegal because minus is the subtraction operator. Forgetting the scope, declaring a variable inside a block and trying to use it outside. Overusing similar names temp tmp temp1, leading to logical bugs. Good practice, use descriptive names, avoid single-letter names except for loop counters and follow a consistent naming style. For example, snake underscore case for variables, upper snake for macros. When the program is compiled, the compiler decides where each identifier lives in memory. Variables. Automatic auto, default for block variables stored on the stack. Memory is allocated when the block is entered and reclaimed on exit. Static, placed in the program's data segment. The value persists for the whole run even if the variable has block scope. External, extern, also in the data segment but with external linkage, meaning the same object can be accessed from other translation units. Constants. Literal constants are encoded directly in the instruction stream or in the read-only data segment.raw data. No separate storage is allocated for each use. Hash-defined macros are replaced by the preprocessor, so they never occupy storage. Each occurrence becomes the literal value. Const-qualified objects are placed in the read-only section of the data segment. The operating system may map this region as read-only, causing a runtime fault if a program tries to modify it. Thus, a const variable behaves like a variable in syntax, but is stored like a constant, protecting it from accidental changes. Multiple choice, which of the following is not a C keyword? Option A static, option B typedef, option C define, option D extern. Answer C define because it is a preprocessor directive, not a keyword. Short answer, explain the difference between hash define max equals 100 and const int max equals 100 semicolon. Hash define creates a macro. The preprocessor replaces every occurrence of max with 100 before compilation. Const int max equals 100 defines a read-only object stored in memory, usually in the read-only data segment. The const version respects scope and type checking, while the macro does not. True or false? A variable declared with static inside a function retains its value between calls. Answer true. Fill in the blank, the identifier while is a blank in C. Answer keyword. Code snippet, identify the errors in the following code and correct them. Define pi equals 3.14, const double radius equals 5.0, double area equals pi times radius, int for equals 10. The identifier pi is undefined. You should use pi or define a const double pi. The declaration int for equals 10 uses the keyword for as an identifier, which is illegal. Rename it to counter. The corrected code is define pi equals 3.14, const double radius equals 5.0, double area equals pi times radius, int counter equals 10.